Hello everyone, welcome to today's webinar, Approaches to Exterior Tile Applications, Old and New. I'm Jim Olson with National Tile Contractors Association. I want to welcome you and thank you for taking time out of your busy schedule to attend today's webinar sponsored by Schluter Systems. Before I introduce today's speaker, I want to remind you that during the webinar you will be muted. Please use the questions area on your computer to type in your questions. We will answer your questions at the end of this presentation. If the audio on your computer is poor, call the number on the invite to this webinar and listen on your phone. All NTCA webinars are available to watch at any time on the NTCA YouTube channel shortly after the webinars are presented, giving you easier access to watch and or share all current and past programs at your convenience. All right, here we go. I'm happy to announce today's speaker, Acker, I call him Andy, is Schluter Systems Director of Education, where he develops the education program and is the lead presenter at the Innovation Workshops. His focus is developing workshops and classes that provide the tiling community with access to industry-approved tiling methods and an overview of how Schluter products can increase the durability of these installations. Before joining the company in 1997, Andy was Andy was a tile installer for 20 years, a little tile installer, I guess, huh? With over half his experience as a California State C54 licensed tile contractor. Andy also serves as the board of directors of the Ceramic Tile Education Foundation, and we are so happy to have you. Andy, have a great show, have a great presentation, and I'll come back at the end with questions. Thank you.
Okay, thank you, Jim. I appreciate this opportunity to come speak to it. You all welcome. I do want to extend my welcome and appreciation for your valuable time. I do appreciate that. We all do. We're all here to learn from each other and share some ideas. And we have a couple of maybe some new ideas or some efforts that have been going behind the scenes maybe a little bit in regards to exteriors, and they're gaining momentum, and we do want to share those with you. Before I go any further, I did want to just show a picture of one of Jim's many little hideouts, retreats that he has. This is a tropical island retreat where he spends some of his winters. So Jim, thanks very much for the picture of your outside deck. We appreciate it. He's not going to even comment to that. So
am I dreaming? Am I dreaming? Do I really have that place?
Well, I must have been trespassing then, because you told me it was okay to go there. So
all right, trespass on my dream. Trespass in my dream. Thanks, Andy.
All right, so in this webinar, we're really just going to cover, well, we're going to cover a lot, but three really things that we want to key in on here about exterior tile assemblies. We're going to take a look and evaluate what the industry guidance is now. What kind of practice do we have? What direction are we giving to those that both specify and install these assemblies? And then maybe some not so traditional considerations, some things that we really should be looking at in regards to having a viable tile assembly in an exterior. Maybe some new thoughts, something to consider. And then maybe some other options that we haven't really looked at that are starting to gain momentum. So that's where we're really going to go. So let's start with the current approaches to exterior tile applications. And where better to start but the Tile Council of North America Installation Handbook. And this is one of the details right out of their handbook. This one says F101, and it's an exterior floor, deck, or patio. It says 20-20, and that's just because it's a couple-year-old handbook. I've got the most recent copy right here. This is the 2021 that I've got here, and it's the same detail. It just says 21, so disregard those last two numbers, but you should probably look for the most current one. And if you look at this one, you can see it's pretty straightforward. You've got a ceramic tile or a glass tile. You're bonding that tile to a mortar bed, and there is an optional membrane that you could put between the tile and the mortar bed. We'll talk about that in a minute, but this is a bonded system. The mortar bed is actually bonded to the concrete slab. And when it talks here in the book about where you would actually use that, it does say for exterior slab on ground construction, uh, where no bending stresses occur and positive drainage below slab is provided, for examples, floors, decks, or patios. This is where an area where leveling, flattening, or contouring of finished floor height is required. So you can see there's a fairly substantial mortar bed that you would bond to the slab, but this would give you an opportunity to actually put a slope into your finished surface, and that's why you have an optional membrane. And it does talk to you about this. If you have a Tile Council of North America handbook, you'll find these. If you don't have one, please contact them and get a copy of this, either in paper form like I have. I'm kind of old school, or you can get an electronic one, but it talks about the membrane options that you would have here. And that would be actually to protect the mortar bed from getting too wet, or the slab, but you certainly should have drainage in there. So that is certainly one approach that you could go with the mortar bed. One that's a little simpler than that is the F102. And you can see this one. This is a thin bed installation. This is where the tile would be bonded directly to the slab. A fairly common approach on a sidewalk or a patio or a lanai, something like that, where you have on ground or on grade concrete placed, and then you're putting the assembly over the top. And again, when you look at this as far as recommended uses for exterior slab on ground construction, where no bending or stresses occur, positive drainage below the slab is provided, and thin bed installation of tile is desired, for example, floors, decks, or patios. So those are a couple of the details that have been around for quite some time and work quite well in many instances. And we'll kind of get into what I mean by many, but not all, but they're there. There are limitations to these, though, and it actually will say right in the books when you see these limitations here. And you can see I put the highlights of their statement right up here on the screen, where it says where installation will be subject to freeze thaw cycles, snow and ice accumulation, and or snow melting chemicals. Degradation can occur over time, and I would even go stronger than saying can to say will occur. So there are some limitations to these assemblies, and we'll look at where we should be looking at these and maybe going to a different system. So we'll get to that in a couple of minutes. But you know, these failures are pretty common when things aren't addressed properly. There's several things that can come into play that aren't addressed, as far as do you have a proper slope away from the structure? What kind of materials are you using? Did you check to make certain all the materials are good? Can you support the load, and so forth? And we're about to get into those. So there are some common failures that we see happening out there. They're typically caused by not proper planning and design and execution, of course, of these type of assemblies. So prior to starting, you need to evaluate the conditions, and we're going to go through quite a few conditions that should be in your requirements if you're specifying or building these that you should be looking at. So let's look at that. And it's very interesting to know that you might get away with taking a shortcut on interiors, but exteriors, there's no such thing as a small failure, and there's no such thing as a shortcut. We have to do everything exactly to plan, and we do need to follow those. So and there isn't any one size fits all. A lot of times we're going to have to look at these very specifically for that particular job site, for that project. A lot of things come into play, and we're certainly going to look at a lot of those too. Let's talk to the manufacturers to make certain the materials are all compatible to each other, and that the materials can withstand the rigors of these environments. That's going to be very important. So make certain that you have a good system, a comprehensive approach, that everything's going to work as you expect it to. And respect these materials. There are limitations to various materials, and we don't want to subject them to an environment where they're not going to perform as designed by the manufacturer. So that could be not only the manufacturer of allied products that are going to aid you in the installation of the tile assembly, but the materials themselves that you would consider the primary material, like the tile. So we have to respect the material. Can it handle that environment? So what are these necessary conditions? Let's go through some of them here. I'm going to go through them here, but I also want to show you there's another place for reference. If you're not familiar with this, this is the NTCA reference manual. They publish one of these things, Jim, I think every year, every other year. This is a 2020 to 2021. This is a great manual, and it does have a section in here. Prerequisites and considerations for successful balconies, courtyards, patios, plaza decks, roofs, exterior walking surfaces, and swimming pool decks. And it's a nice couple of pages in here giving you a lot of considerations. I don't have time to really read a lot of it right now, but a lot of the highlights from these 2 pages are going to be also in this part of the presentation. So structural suitability. Let's make certain that when the original deck or balcony was constructed and designed, it was designed to hold the load. You know, tile assemblies are not light. So in this case, you can see where perhaps an exterior deck was originally designed, or the thought was that we were just going to do a wood deck or some sort of composite plank assembly. And then someone got an idea, why don't we tile it? Typically by that time, it's too late to switch over to to this type of material. And we'll talk about that a little later. So can we handle the load? Do we have adequate slope away from the structure and or to the drains if there's drains that are located in the surface? So we need 2% slope. That's about a 1/4 inch per foot. So if you have a 12-foot deep deck away from the structure, you're going to have 3 inches of fall from the structure away to the edge if that's where you're actually sloping the thing. So you have to put that, all that into consideration. We need to get the water to sheet off of this thing, regardless, and I know this is hard, regardless of what the consumer desires as far as wanting a flat deck so they can sit there comfortably, they can put their tables and chairs and dine outside. We're still going to need a 2% slope to that finished surface. And in many cases, if it's a system where we're allowing water to get in and drain out, which we'll show you a little later, you're going to need that 2% down there at the primary waterproofing membrane also. How about clearance as far as height from inside to outside elevations? We would really like at least 3 inches and maybe comfortable to 4 to 6 inches is what I hear. I've just read in the National Tile Contractors Association reference manual. From finished elevation inside to finished elevation outside. Why do we need that much drop? To get flashing to work properly. We need to make certain that we can flash onto the structure, onto, as you see here in the picture in the lower left, we do have it looks like a set of French doors, and we're going to have a threshold on there, and we should have a really nice apron and saddle all molded in there before the door is installed that actually hangs down over, and we can flash up under. So we can get flashing and counter flashing. Also, if you have stone or masonry, you should be actually putting in what's called a reglet, which is a small cut into the stone where you actually put another piece of counter flashing that hangs over your flashing that's coming up from your deck. So that's why we need that adequate clearance. Now, that's another thing the consumer doesn't really like, is a lot of elevation change from inside to out. But unfortunately, there aren't a lot of options, but I am going to show you one here towards the end of the presentation, which is getting very popular. And that's one of the reasons why it's popular, is because the consumer wants that even transition from their living space inside to the living space outside. We can do that, but it's going to be a specific application. How about getting all the water out of the assembly, whether it's surface water or water that's got into the assembly? We need to make certain we get that all out of there. We don't want to keep any water in there because you could have a lot of problems. Freeze-thaw cycling, of course, the water's going to freeze and spall the assembly apart. It could just be efflorescence or a massive amount of free lime or calciums or binding salts, whatever term you want to use, that is leaching through the assembly, in many cases clogging up drainage. So we need to get water evacuated and keep it from getting on assembly, in the assembly, and get it out of there if it does get in. How about railing? Now, it's a great practice to not even interrupt the waterproofing with the railing or any sort of penetration. So you can see in this photograph, it would be a great idea to put it in the fascia or even the underside of this balcony that's hanging out if you can. So It's always a good idea to keep that away from not only from the waterproofing, but when the tile wants to expand and contract due to thermal changes, you're going to need to leave a lot of room around any kind of railing or post that you're putting through there to allow the tile to move independently and not be pinned in by any kind of a column or a post or a standard or anything. How about movement joints? You know, there's a lot of movement joints that are needed in exterior. And if we look at our Tile Council of North America handbook and we go to the movement joint page, it will tell you that in an exterior, they should be as frequent as every 8 to 12 feet in each direction and around the perimeter where they're going to meet any restraining surfaces. And you'll find that right here in EJ 171 in our Tile Council of America handbook, North America handbook. So another good thing to take a look at and make certain you're taking that into consideration. Again, aesthetics aside, they are absolutely required on all tile assemblies, and certainly exterior, where we can get a lot of heat and a lot of moisture. And those are two of the conditions that make materials change their dimension, isn't it? Moisture content, thermal change, that'll make a material change dimension. So we really need to accommodate that kind of dimensional change that's occurring in our tile assembly by introducing soft joints, movement joints, expansion joints, depending on how you're designing your assembly. And again, we already touched on this, material suitability, certainly the tile. What color is it? The darker the tile, the more heat it's going to generate, and it's going to get warm. That's going to cause excessive heat in the assembly. Are you putting this down in the hot climates of the country or up cooler? Is the material suitable? We should really be looking for a tile that has very, very low water absorption rate, like a porcelain or something that's a frost proof. And if it's going to be a natural stone, 0.5% moisture content, which you start looking for natural stones that have that low absorption rate, you're going to be limited to your selections. But still, those materials, the bond coat, the grout, anything that you introduce into this assembly, we should look at the suitability. Is it going to work in that environment? And of course, coverage. We don't want any area under the tile and in the assembly that can actually accumulate water, any void that can actually fill with water. We want 95% coverage. That only means 5% maximum void area under the tile there, where it's not making contact directly with the substrate it's bonded to via the bond coat, via, say, the thin set. So certainly coverage is going to be very important. Another thing about material suitability, what is its coefficient of friction, wet and dry, as far as slip resistance? You're going to want to take that into consideration to make certain that if it does get wet, that it's not going to be a slip fall hazard. Okay, and how about the conditions actually while you're installing the assembly? You have to have very regulated conditions. You'll see that many times the bond coat, the grout that you're going to use, requires a prolonged period of being secured to be very safe, to let it cure at a nice slow rate, not accelerated by excessive heat, not frozen because of cold. You know, if it's a cold climate, if it's a warm climate, you need to provide a very controlled environment for this assembly to be installed and cure in. And they're going to differ, and we'll get into maybe some of the bond coat issues here on that you should be looking for. But certainly, is there a tile setting season exterior? Well, where I hail from in Northern California, it was longer than where I live now in Kansas City, Missouri. You can certainly see that the weather is more extreme here where I live currently than in the San Francisco Bay Area. So yes, there is a tile setting season where it's optimal conditions. So that should be taken in consideration. And if you can't, you can see from the image here, you need to create those conditions if they're not there naturally. So all these requirements are crucial. And I tell you, after being, I hate to say it, almost 45 years in the tile industry now, I've seen lots of failures, and a lot of them come down to the things that I shared with you and the things that you can find in your reference manual here as far as all the considerations. They were not taken into consideration. They weren't applied. And like I said earlier, one thing will make one of these things go south real quickly. So So if you can't meet all those requirements, you really shouldn't be participating. You really shouldn't be trying to specify these kind of assemblies over these type of substrates. And in many cases, as I saw through years and years, typically someone's mind was changed as far as what we were going to put on the surface, and tile was selected way after the fact, way after where we should have actually considered tile and everything that I just shared with you as far as what conditions do we need to have the best chance at a successful installation. How about some of the newer considerations that are out there? Let's take a look and see what some of the new thoughts that are going around, bouncing around in the tile industry. Jim and I both attended the Covering Show last week in Las Vegas, Nevada. It's the largest tile and stone show in the United States annually. And there's a lot of thought leaders, opinion leaders, people who are leadership in our tile industry, from the manufacturing side, from the governance side. And these things are being shared, so I wanted to share them with you too. So what are the things we should really be taking a look at that haven't always been considered but are really crucial to the success of an assembly? How about we look at climate zones? We'll see that those play a crucial role. How about adhesive mortar considerations? There are going to be specific considerations, specific types of performances that we're going to need in order to ensure success. And then how about who's responsible for what when we actually design these things and build them? So let's start with the first one, climate zones. What is it about climate zones? Well, you look at this one here from the United States Department of Agriculture. You know, we're all probably pretty familiar with this. If you do any gardening, if you have any landscaping around your where you live, where you visit, you can see that there's different zones based on what's going to make it through the winters or the hot summers. Is it heat? Is it cold? Is it the amount of precipitation? All these things come into factor, and you can see that there are different zones here, and I think that's important to take a look at. Not only them, but let's take a look at the Masonry Institute or the insulation industry, or when it comes to factoring in windows and doors. All of these industries, all of these organization groups have their own climate zones too. So this is something that we should take heed of and say, yes, in the tile industry, we should be really paying attention to what is the climate zone where we're going to put our assembly. And that should play a significant role and factor in how you determine what you're going to build and with what you're going to build. For instance, you can see here on the screen, USDA Zone 6B. Look at the climate. Look at the extreme low temperature, below 5 to 0. Could it get that low? Fahrenheit, of course. Or in 10B, look at where you would be a lot more mild climate. So let's not do one size fits all. Let's look at climate zones and see what's going to be adequate where in our different regions around the country. And let's take that into consideration when we actually specify and design an assembly. So we really do need to look at the local conditions. There can be microclimates, but certainly the climate bands I showed you can come into play, and they need to be able to withstand to these local conditions. That's something that should definitely be taken into consideration. How about adhesive mortar considerations? Well, when you get to mortar considerations, there's lots of bond coats on the market. A lot of them will just say simply, it's suitable for interior and exterior, but that does not always mean it's suitable for every climatic conditions. Sometimes you're going to have to look a little closer and be a little more specific about exactly the performance values you're looking for based on these exterior climate zones and the extreme temperatures and the rigors of this environment. Heat, cold, wet, dry, all these things come into play. So also look for that. Is it going to make it in that very climate condition? Not just because it says interior, exterior. Almost everything set will say that. You have to be more specific, and we'll get to that in a minute. So if you have extreme temperature variations, you need to use a mortar with a high shear bond strength. Now, all these mortars are tested by industry groups and by the manufacturers themselves to actually measure shear bond strength. And what shear bond strength really indicates to you is the quality of that bond coat. How much stress can it take in a shear before it actually breaks a tile free of a small little concrete block that it's bonded to. That really does give you a really good indication of that, but also some flexibility. If you're going to do a direct bond like some of those systems I showed you, you're going to need some flexibility within the bond coat, not only high shear bond strengths. If you use a membrane, which allows independent movement between the tile surface and the substrate that's below it, the flexibility isn't of your utmost concern as much as it is in a direct bond assembly. So keep that in mind. And I showed you those details earlier, and I'll show you a couple more coming up that actually say membrane optional. And when it has the membrane optional on top of the mortar bed or on top of the substrate you're going to bond to, this is one of the things they're referring to. It's not only for waterproofing and crack isolation, but it could be also in there to uncouple or isolate the tile from the dynamics that are occurring in the substrate below the tile, in the tile assembly below the actual finished veneer. So remember that all of these materials change dimension at a different rate and to a different degree depending on their material composition. And again, like I said earlier, how much heat, how much moisture are they going to be exposed to plays a great role in how much dimensional change those materials can have also. Found it very interesting that one major bond coat manufacturer out there actually says in their white paper about exteriors that if you have an environment that's prone to freezing, you should be using a mortar that is specifically approved for freeze-thaw cycles. That's pretty common. You can also see other types of quotations. I put this in quotation because this was from one specific manufacturer that is actually leading people into one of their thin sets that they say is a high-performing calcium aluminate base. In other words, what they're trying to do is eliminate the opportunity for a lot of the free and active calciums or binding salts, the free limes that are so prevalent in Portland cement-based materials, whether it's masonry or tile assemblies. They're trying to minimize the presence of that, which keeps down the amount of that calcium that can actually become free and make its way through the assembly and perhaps even clog up the drainage that you've designed and built into the assembly. So I found that really interesting that this manufacturer said, yeah, let's go towards these. Not only that, but they cure controlled, but they are going to get to a very high percentage of their cure in a very short amount of time, which means your protection time to allow that to cure can actually be lessened. So that might be a good consideration. All right. Now, how about scope of responsibility? I know this one has been kicked around for quite some time, but I want to show you this table. And if you would, take a minute to study it. We've got basically three different disciplines here. We've got the design professional, we have a roofing professional, which many people haven't even really considered much, and then you have the tile installer. And then the task involved there, you can see the design professional is going to be involved in almost all aspects of this. The design professional is really key to making certain, as I said earlier, that all the materials are suitable, that they can handle the rigors of the environment, that they can work together, and they're going to play a major role in evaluating all of these things that you see. But then you enter the roofing professional, and this is where this kind of an idea that we're trying to gain traction in the tile industry is occurring, where we feel that the tile installer should not play the role as the roofer in introducing the primary waterproofing. The secondary waterproofing on top of a mortar bed, as I mentioned earlier, certainly they can play a role there, and that might be part of your assembly. But when you get to the primary waterproofing membrane, the roofing membrane, that should really be done by a qualified and trained, experienced roofer who knows how to put down waterproofing over something as low pitch as a deck or balcony or something like that. So this is certainly where the roofer should play their role, not the tile installer. The tile installer should simply come in and put a tile assembly on top of a functioning roof. That's the roles that we really should be playing. Design professionals should be able to call this out. They can work with the roofer to have suggestions on the type of materials that could be put on there and application. Certainly the design professional should ask the opinion of the tile installer in regards to the tile part of things, but you can see how each one's role should really be where they're in their area of expertise. And that's going to really lessen the amount of damage we find and the amount of mistakes that are made. I just find too many tile setters are being put into place to be the roofer, to actually introduce the primary waterproofing membrane. And more and more people in the industry are starting to go that way and say, yeah, that is a role that we should shy away from. Certainly over living space, if there's living space below the deck or balcony. But even if it isn't open space underneath there, so much damage can occur, and you will assume all that liability, not only for the damage to the tile assembly, but any damage caused by, say, a leaky roof or something like that. So take that into consideration. This, again, many of us in the tile industry feel strongly that this is the direction we should be heading. So what if a failure does happen? Well, you really should have a very objective party show up and do a good evaluation, do a forensic study, and find out exactly what went wrong. Not to place blame, but to keep it from happening again. You know, it's funny when you look at well, it's not funny at all. It's ironic when you go out and look at some of these assemblies that I've seen after 45 years of being in the industry, that it's not usually just one thing, but it could be just one little thing went wrong, but usually a litany of errors. But you really need somebody that's going to be objective to go out and say, this is what went wrong, and this is what we're going to do to prevent this from happening again. So when a failure happens, the problem is it's rarely a quick fix. We've seen a lot of stuff tried to be patched up. It typically doesn't last much longer. You get another season or two out of it. Unfortunately, most of the time, it's a complete removal of the tile assembly in many cases to actually repair damage that's below the tile assembly and then to build back up. So, you know, really we should be taking a look at this. And many of you have heard this before, and I think this is a perfect application for this here. We don't want to do it again the same way we did it last time if it failed. We really need to figure out what went wrong and how to do it right. Based on a lot of the factors I've shared with you so far, let's take a look at climate zones. Let's take a look at suitability of materials. Let's take a look at all of those other environmental concerns that we have, that we shared with you, as far as having a slope and elevation change and no railings and no penetrations and movement joints, and all the materials are suitable. With all of that being said, and then the climate zone, of course, we want to look at all of these things and say, are we going in the right direction based on it? You know, let's do it right the first time. It always amazes me. There's never enough money to do it right the first time, but somehow it's always found to replace it and do it right the second time. Although I've seen many cases where they put it back in the exact same way it was put in the first way, and you know that that's just a limited lifespan on that, certainly. So let's look at some other options for some exterior successes here. Here's another unbonded assembly. This is not a bonded assembly, which is going to give you some of the original true nature of tile assemblies going clear back to, you know, thousands and thousands of years ago. Certainly back before the Roman era, where we had unbonded screeds and unbonded tile assemblies that really did isolate the tile and protect it. But you can see here that this is an unbonded mortar bed. You can see that this works quite well, and there will be a cleavage membrane. And the cleavage membrane is where you're actually going to get some movement, some forgiveness in the shear plane between the tile assembly and the structure below. And this is F11120. You can find all of these details in your handbook. Certainly, this is a good one to take a look at here. Here's another one. This, again, is an unbonded assembly, but you can see it's a very thick assembly, F103. The reason that this one's really picked, again, is because you're going to create a slope. This one can be very heavy, though. This one can be somewhere upwards of 31 pounds per square foot of dead load, just for the tile assembly. So certainly that has to be designed in and engineered in to carry that kind of weight. But in many cases, what we're doing here, is we're actually allowing the water to drain out the bottom to try to keep that tile assembly as dry as possible. You are going to need a 1/4 inch per foot of slope at the drainage layer, which is at the primary waterproofing under the whole tile assembly, and another one you can see, an optional one up on top of the mortar bed, just under the tile, from trying to keep as much water from getting into the assembly to begin with. So that's a real good exercise. This will be actually a good assembly to be used in many of the climate zones that we have around the US. Another one here, this one actually incorporates a drainage mat. So it's still the same principle as the method I just showed you, but here we've actually got a manufacturer type of drainage mat, which can actually reduce the weight from, say, 31 pounds per square foot down to 21 pounds per square foot. So you can save a tremendous amount of dead load weight by going into one of these type of assemblies, which function the same way. If any water gets into the assembly, it's able to get out the bottom. These are also going to be very important if you have heated or cooled space, conditioned space underneath the tile assembly, that you have an air gap for the air to get up in there right at what's called the drainage mat layer there. And this will happen on the gravel too, to a certain extent, where you allow air to get back up in there and actually dry that out. And if you do get a dew point in your tile assembly, it's on top of the waterproofing, not in the ceiling cavity below it. That's certainly could happen if you have a conditioned space. So you want that dew point outside of your waterproofing so that the waterproofing layer and the drainage layer can play its role. So keep that in mind. All right, so some manufacturers have comprehensive systems where they have thought about all of these different factors. They've thought about uncoupling the tile from the structure, from the substrate below, also allowing drainage to get out of the tile. If you're using a tile that could absorb some water, like a natural stone down in Florida would be a good example, very popular down there. You want to keep that stone as dry as possible, and the grout and the bond coat. Anything that's on top of the membrane, you want to keep it very dry so you can actually have drainage incorporated into your membrane that will allow the water to get out. You know, water does follow the course of least resistance, so this will greatly minimize the amount of efflorescence, the amount of that binding salt, that free calcium, that lime that's coming up through the surface. With the water being the vehicle to bring it to the surface, the water evaporates, leaving those calciums behind. It's unsightly. It's not really a failure, but it is a sign you have excess moisture content in the assembly and it's trying to get out. And the way it can get out readily is through the top. If you put a drainage mat in there, then you wouldn't have that. That's just below the tile. The other one is a drainage mat that you would put below the mortar bed and over the primary waterproofing. There's ones there that you can do on grade. There's thick elevated ones. There's all kinds of flashing details that manufacturers will make for you, so you can do perimeter flashing and waterproofing, flashing to the actual structure, and of course movement joints too. So do partner with a manufacturer that has a comprehensive approach to these, because they will actually help you think the whole thing through. So keep those in mind too. You can see photographs and stylized drawings of some of these assemblies here. So that would be another, certainly a good avenue to pursue in many of the climate zones. But what if you're trying to just avoid this altogether? You're saying, oh my gosh, Andy, you've given, my head is about to explode. You've put so much fear in me. I don't know if I ever want to specify one of these things or sell one or install one again. It's like, well, you know, again, the things we're trying to show you is to be provide you a certain amount of cautionary tale here, right? I think it's a good idea to be a little afraid of these things. Approach them with a little bit of fear is not a bad idea. Know what you're up against, but you can see the type of things that will occur here. The tile can be disbonded. You can get freeze-thaw spalling and rupturing. Broken tile and grout, of course, can happen here if you have direct bond systems that don't allow for any flexibility, and you've got differential movement between dissimilar materials. Just degradation, as we read earlier from the Tile Council book. That efflorescence, again, it doesn't constitute a failed tile assembly, but it does show you have excess moisture that's trying to get out. Unfortunately, it's trying to come back through the top. Latex leaching can be a case. If you have a thin set that has high latex content, which many of the flexible ones do, remember, latex doesn't cure, it coalesces. Portland cures. So you need to create an environment that allows those latexes to fully coalesce before they ever are subject to any water, or any free and active latexes can actually, let's call it, reanimate or re-emulsify and make their way out of there. You'll get latex leaching. So we need to, again, go to those mortars specifically made for these kind of environments where you could get a polymer modified, a latex modified thin set, but it's going to actually kick off in a short amount of time. So all of these things are important that you take into consideration. Check with your manufacturer. Do you have a bond code that meets all my requirements in this area where I'm going to do that? But here is a great example of one of the alternatives that's really gaining some traction in our industry. And I've got 4 different examples of some of the leading manufacturers of these pedestal systems out on the market currently. These are all readily available. I just saw them last week, discussed these type of issues with the manufacturers in their booths at the show, and came away very enthused about this as an alternative. So certainly this could give you a nice exterior, and it's an unbonded system. So there is no mortar bed. There is no thin set bond coat. There's no grout to cause some of these other problems. So where can you put these? You can put them on slab on grade, above grade, rooftops, all over the place. When I've gone over to Europe and visited there when it's not the outdoor season, I found many of these locations, hotels, they actually pick up their paver system and go store it for the winter. And they're able to do any maintenance or inspection on their primary waterproofing membrane, their roofing membrane, on their deck, their plaza, while they've lifted this thing up and stored it for the winter. And then they bring it back out and put it up in the spring. You don't have to go through that. Many of the pavers that are out there can withstand, the harshest climate. So I'm not suggesting that, but I thought that was interesting that they actually did that. So there's many applications. So where does the water drain? Right down to what used to be the grout joints, and they're just gaps in the pavers. So this is the water allows to readily flow and drain right off of the surface and get down to the primary waterproofing underneath. I can't identify this particular manufacturer. I don't need to, but you can see another system here. You can go over the ground covering, roofing membranes, and you don't have to have a slope to your finished surface. This is where the consumer really likes this, because you can build a completely flat service area that they're going to enjoy, but you can still have the drainage and the slope away from the structure to the drains, over the edge to the flashing, however you're going to design your assembly. So it actually meets both requirements aesthetically of the consumer and technically to the design professionals and so forth. It's also nice, as I said earlier, because you can actually do maintenance and cleaning. You can get to underneath there. You just lift up these fairly thick, heavy pavers and get to the underside, put them back in place. Also great ventilation, so you don't get the heat, you don't get the cold. You can have that area in there as an air gap. So keep those in mind. Frost resistance, of course, is going to be very important in many of our climate zones, as we looked at earlier. Certainly an assembly that works well in Florida is not going to be something that's exactly what you're going to want to do in, say, Michigan or Minnesota, right? So that's the kind of thing. So let's make certain that we're looking at these type of assemblies. So a lot of adjustability in these assemblies, from very thin assemblies up to very tall pedestals, depending on how much fall you have. And then you do get that level transition between interior and exterior. Yes, we've done flashing properly. Yes, we've got the amount of fall down to our waterproofing and our slope. But as far as the consumer, the end user is concerned, they can get that nice even transition from outside inside. So, which is what many people like. Whenever we go over to the Hawaiian Islands, this comes up all the time, that people want that even transition from their indoor living space to their outdoor living space, which, if you've ever spent any time in any of the tropical climates, a lot of time, windows and doors are an afterthought, right? So it's kind of blurred between what's indoor and outdoor. They want that seamless transition, and you can actually provide this with them, and they get the aesthetics, you get all the function and design that you actually need. So uneven substrates aren't a problem. You can go from one elevation to another and still have your finished surface perfectly flat and level. So keep that in mind. So really, the 3 major takeaways from today's discussion would really be, we really shouldn't be putting the tile installer in the role of the roofer. We should get a qualified roofer to play that role with direction from a design professional. We should be looking at climate zone characteristics. Certainly other industries are, and you can see why and understand why they would take that into consideration, and we certainly should too. And then also, let's put the tile professionals into these unbonded systems, or if you're gonna have to bonded system, that we take into consideration all the materials that are gonna go in. What climate is it gonna go in? Maybe there are some climates where we really shouldn't be looking at bonded systems altogether. And then, yeah, let's put the waterproofing on into the right party that does that. So those are really what I wanted to cover today. That's really where the tile industry is having discussions currently. So look, stay tuned for further developments. We could certainly be going in this sort of direction. So that's really it for the end of my part of the presentation. It looks like from my timer, we have a few minutes. If anybody wants to ask a question or post a question, or you certainly are welcome to do that, and I'll try my best to answer them if I could.
Well, Andy, as usual, you've done such a great job that we only have one question at this point, unless anybody wants to write in. Oh, others are coming in, but I think you may have answered this first one, and it just is, what recommendations are you providing for CM, 2 CM and 3 CM porcelain tiles? Are you looking at installations laid directly in formulated sand and managing moisture, I think, along with pedestal systems, right?
I think both of those were perfect solutions, Jim, what you just said. We could do a formulated sand, we could do a gravel bed. Certainly sand set lasts for a very, very long time. The whole idea with 2 or 3 CM supported under load, we'll see what kind of load they'll actually get there, but then also get the water out of the assembly as readily as possible. And certainly the pedestal system is a direction for your 2 and 3 CM. There's a lot of manufacturers that are making that thick a material out there for that very application. It's not that it can't be direct bonded, it can, but I think they're really starting to steer towards those pedestal systems we looked at earlier.
Exactly. Do building codes require a greater slope than 1/4 inch per foot? And then he went on to say 1/2 inch per foot minimum. And I think you addressed that, but
yeah, right now the code is 1/4 inch per foot, which you don't think is a whole lot, but water will sheet off 1/8 of an inch per foot quite readily. But a 1/4 inch is great. But the thing is, you need to keep in consideration, it doesn't seem like much, but as I gave that example, a 12-foot deep deck coming off of the edge of a home. You have 12 feet, 1/4 inch per foot, you do the math, you got 3 inches of fall between where it's at the structure to where it's at the edge, if it's all sloping and sheeting off. So it does get to be quite a bit of area to manage as far as elevations. So 1/4 inch per foot would be a good rule. And also on top of that, I should stress again that our elevation change from inside to outside should be a minimum 3 inches. And Jim, I know you're very familiar with your book here, where you guys are actually saying something, I see, consider approximately 6 inches above finished surface to allow appropriate waterproof flashing onto the vertical surfaces. 6 inches is a lot of area, but I can certainly see where that could play it safe. If you've got snow load and you'll have snow up against a home, I can see where 6 inches could be something. So 1/4 inch per foot, and make certain your flashing extends well up behind the siding, up behind the other waterproofing, masonry, whatever happens to be on the structure.
very important, yes. Is the exterior TCNA standard written in the main book, in the TCNA handbook? Is that what you went through? Is that in there?
Is the standard in here?
Yeah.
It's not actually, it's referred to. The standards are referred to, but you'd have to go to the ANSI book. That would be A108, right, Jim? For installation?
Yep, correct. A108 installation, and it will be in there. It will not be, as Andy said, it's referred to, but it's not written directly in there. So
they do, yeah, they do refer to it, and that's what they're referring to as ANSI 108, which is the installation standards specs.
And let's see, edge details on pedestal systems. Is there edge details anywhere for pedestal systems? because they're very
They're-
unique and different,
Yeah.
many varieties.
Yes, and I'm glad whoever brought this, that's a great reminder. I should have brought this up when I talked about pedestals. Right now, you'll find that there's a minimum of pedestal systems that have a fascia or edge detail, or maybe riser coming from a set of stairs, that first riser off of the deck. So you're going to have to look for the ones that have that type of assembly there. Another thing that I didn't bring up, if you go into a hurricane region of the United States, you'll find that many of the counties in those regions are requiring that these pedestal systems actually be affixed to the structure. They have to have an anchoring system built in. That's going to minimize the ones that are available too for that location. But yeah, I'm glad you brought that up. Typically where we're seeing pedestal systems utilized currently because of those shortcomings are where you have verticals all the way around, maybe the structure and pony walls, parapet walls, curbing, something like that. That's what we're seeing right now. But stay tuned. The manufacturers, including the one that I work for, are working on a clip-on system, different types of ways to affix a fascia so you can have a nice finished fascia there around the perimeter of those. So yeah, great question.
I think we're going to see a lot of updates and new ideas and new things coming. This is very popular right now, and kind of excited that it's a new avenue to really put tile and stone in, and it's great. So,
Well, if you think about it too, the folks that can put these in, the tile installers, are perfectly capable of putting these pedestal systems in. First one, you'll kind of go, oh, I've got all these little parts, and this screws up, and this has a pad, and it compensates for the slope, so we get it shimmed level. But really, after your first one, you'll go, I got it, I'm an expert. And then, of course, what are you doing? You're just placing these large 2 and 3 cm or maybe even thicker, assemblies on top of the pedestal, and you're done. You didn't play a role in the waterproofing. There's no thin set. There's no grout. Maintenance is minimal, and so forth. So yeah, it could be really, like you said, Jim, a perfect example of a new avenue for some work.
and don't be afraid of these pedestal systems. If you work with the company that sells the pedestal systems, they actually help you lay it out on where it needs to be and give you all the details. They'll work with you hand in hand to make sure it gets done right. So
Yeah.
it's another just great option for putting tile and stone in a great outdoor area, beautiful area. So
Yeah, you're right, Jim. I haven't met a single pedestal manufacturer that won't help you with your actual material list. Go
yeah.
right through the list, give you every single piece you need around the perimeter, around in the center, what heights, you got your elevations all there. They'll work with that and come up with a complete piece by piece material list for you. So yeah, they will.
Yeah, I've seen where they've actually done the layout like on a grid pattern and everything. They'll put it down there for you and show you where every piece should go and every pedestal, all of it. So
Sure.
look into it, you guys, everybody. I think it's a great opportunity. Andy, I want to thank you for another great presentation, bringing up great technical information, but also ideas on how we can continue to grow our industry. It means a lot. I thank you. And I think you'll be back in October to do another program for us, and looking forward to that. Everybody, I hope those of you that went to coverings, you got home safely and soundly and had a little sleep in between now and today. So coverings in Las Vegas tends to take a lot out of all of us. So, enjoyed this, Andy. Thanks, everybody. Please look forward to our next invite for our next webinar, and we will talk soon. Thanks, everybody.
Thank you. Bye-bye.